A drone takes off from hundreds of kilometers away. A missile crosses an entire country. And somehow they both strike a target with near perfect precision. There is no pilot, no last-second correction, no human guiding them in real time. So what is actually making this possible? Most people think it is advanced AI or powerful weapons or some kind of futuristic targeting system. But the truth is much simpler and much more unsettling. The most important piece of modern warfare is not a weapon at all. It is something you cannot see, something silent, something orbiting far above the earth. Without it, drones would slowly drift off course. Missiles would miss their targets, and entire armies would lose their sense of direction. Because modern war is no longer just about destroying things. It is about knowing exactly where everything is at every moment. And that knowledge comes from a system you use every single day, but almost never think about. Most people think power in war comes from how big the explosion is, how fast a missile travels, or how destructive a weapon can be. It feels intuitive. If something creates a larger blast, it must be more powerful. If something moves faster, it must be more dangerous. For most of human history, that assumption was actually true. Armies tried to build bigger bombs, stronger guns, and more destructive weapons because raw force decided the outcome of battles. But modern warfare quietly changed something fundamental, and most people did not notice it. The focus shifted away from how much damage a weapon can create and towards something far more precise, far more controlled. Because in reality, a weapon that is incredibly powerful but misses its target is almost useless, while a much smaller weapon that lands exactly where it needs to be can completely change the outcome of a conflict. This is the part that feels counterintuitive. Power is no longer about how much energy you release. It is about where that energy goes. A massive explosion in the wrong place is just noise. But a small, precise strike in the right place can disable infrastructure, destroy a key target, or eliminate a critical system. The difference is not the size of the weapon. It is the accuracy of the position. If you think about it, every action in war can be reduced to a simple problem. You need to know where you are. You need to know where the target is. And you need to move something from one position to the other. That is it. Everything else, the speed, the fuel, the explosive power, all of it only matters after that basic problem is solved. If you fail at the level of position, everything built on top of it collapses. This is why older weapons often relied on estimation, visual targeting, or sheer volume of fire. If you are not sure where the enemy is, you compensate by firing more, by covering a larger area, by increasing the probability that something will hit. That is why wars in the past were often inefficient, chaotic, and incredibly destructive across wide areas. The lack of precise positioning forced armies to rely on excess force. Modern warfare does the opposite. Instead of increasing force, it reduces uncertainty. Instead of guessing, it calculates. Instead of spreading destruction across a wide area, it concentrates it into a single point. And once you begin to see war this way, everything starts to look different. The most important question is no longer how powerful a weapon is, but how precisely it can reach a specific location. This shift changes everything. It changes how weapons are designed, how missions are planned, and how decisions are made. A commander does not just ask how strong a strike will be, but whether it will land exactly where it is intended because if it does not, the strength of the weapon becomes irrelevant. Accuracy has quietly replaced raw power as the defining factor of modern conflict, and this leads to a deeper realization. If accuracy is the true source of power, then the real question is not about the weapon itself, but about the system that makes that accuracy possible. Because a drone, a missile, or a bomb does not become dangerous simply because it exists. It becomes dangerous when it knows exactly where it is and exactly where it needs to go. At that point, the weapon is no longer the center of the story. The real power lies in the invisible system that provides position, the system that turns movement into precision and precision into impact. And once you understand that, you start to see that modern warfare is not built on explosives. It is built on something much more fundamental. To understand why position has become the center of modern warfare, we need to understand what GPS actually is. Because most people have a completely wrong idea about it. When you open a map on your phone and see a small dot showing where you are, it feels like the system is simply tracking you, almost like a radar or a camera watching from above. But that is not how GPS works at all. GPS does not see you. It does not know where you are. And it does not send any information back to space. Instead, it does something much simpler and much more elegant. It only sends signals. And those signals contain one thing: time, high above the Earth. There are satellites constantly orbiting the planet. Each of these satellites carries extremely precise atomic clocks, and they continuously broadcast signals that include the exact time those signals were sent. These signals travel at the speed of light, spreading outward in all directions, passing through the atmosphere, and reaching the surface of the Earth. Now here's where the real idea begins. A GPS receiver, like the one inside a phone, a drone, or a missile, listens to these signals. It does not ask the satellites where it is. Instead, it measures how long each signal took to arrive. And because the signal travels at a known speed, the receiver can calculate the distance to each satellite. If you know your distance from one satellite, you could be anywhere on a huge sphere around it. If you know your distance from a second satellite, your position is narrowed down to the circle where those two spheres intersect. With a third satellite, that circle becomes two possible points. And with a fourth satellite, the system can resolve the exact position in three-dimensional space. So GPS is not a map. It is not a tracking system. And it is not a camera in the sky. It is a geometric solution to a timing problem. It uses the difference in arrival times of signals to calculate distance, and from distance, it calculates position. Everything comes down to time. Measured with incredible precision, this is why even tiny errors in time can create huge errors in position. If the timing is off by just a few nanoseconds, the calculated position can be wrong by several meters. That is why GPS satellites rely on atomic clocks, because they are stable and accurate enough to keep the entire system working. Without that level of precision, the entire structure collapses. Once you see GPS this way, it stops feeling like a mysterious technology and starts to look like a very clean piece of physics. Signals move at a constant speed. Time can be measured, and geometry can be used to solve for position. That is all it is. But from that simple idea, something incredibly powerful emerges. Because if you can calculate your position anywhere on Earth, at any time, with high accuracy, you suddenly remove one of the biggest sources of uncertainty in any system that moves. A drone no longer has to guess where it is. A missile no longer has to rely on visual guidance. A unit on the ground no longer has to estimate its location based on landmarks. Everything becomes measurable, calculable, and precise. And this is where the connection to warfare becomes unavoidable. Once position can be known with precision, movement can be controlled with precision. And once movement can be controlled with precision, impact becomes predictable. At that point, the difference between hitting and missing is no longer luck. It becomes a matter of calculation. So GPS, at its core, is not a weapon. It is not even designed for destruction. It is simply a system that answers one question with extraordinary accuracy. Where am I? But when that question is answered perfectly, everything built on top of it begins to change. Once you understand that GPS is simply a system that tells you exactly where you are, the next step becomes unavoidable. If position can be known with precision, then every action in warfare can be reduced to a problem of position. And once you see it that way, modern war starts to look very different from what people imagine. At its core, every military action follows the same structure. You have a starting point. You have a target point. And you need to move something from one to the other. That something could be a drone, a missile, a bomb, or even a group of soldiers. But the logic does not change. The entire operation depends on knowing where things are and where they need to go. In the past, this process was filled with uncertainty. Armies relied on maps that were often outdated, on visual landmarks that could be obscured, and on estimates that were never fully reliable. Even small errors in position could lead to large errors in outcome. A unit could miss its objective. Artillery could land far from its intended target, and coordination between different forces could break down. Because of this uncertainty, warfare was often inefficient. To compensate, armies used more force than necessary. They fired more rounds, covered larger areas, and accepted a high level of collateral damage. The logic was simple. If you cannot be precise, you increase volume. Accuracy was limited, so destruction was spread out. Modern warfare reverses that logic completely. Instead of increasing force to compensate for uncertainty, it reduces uncertainty to increase precision. When you know exactly where you are and exactly where the target is, you no longer need to rely on guesswork. You can calculate a path, adjust it in real time, and deliver something to a very specific point in space. This changes the nature of power itself. A weapon is no longer defined primarily by how much damage it can cause, but by how precisely it can deliver that damage. A missile that lands exactly on a critical piece of infrastructure can have a far greater impact than a much larger explosion that lands hundreds of meters away. The effectiveness comes from alignment between position and intent. And this is where timing becomes just as important as location. It is not enough to know where something is. You also need to know when it will be there. Movement through space is always linked to movement through time. A drone adjusting its path, a missile correcting its trajectory, or multiple units coordinating an operation all depend on synchronized knowledge of both position and time. So modern warfare becomes a continuous process of updating information. Systems constantly measure where they are. Compare that to where they need to be and make small adjustments to reduce the difference. This loop repeats over and over again, sometimes many times per second. The result is not just movement, but controlled movement, guided by precise knowledge. When you look at it this way, The battlefield is no longer just a physical space filled with weapons and forces. It becomes a network of positions, constantly measured and updated. Every object has coordinates. Every movement has a trajectory, and every action can be described in terms of location and time. The complexity of war is still there, but underneath it is a very simple structure. And this leads to a realization that feels almost surprising. Modern war is not fundamentally about destroying things. It is about solving positioning problems under extreme conditions. The side that can measure position more accurately, update it more reliably, and act on it more quickly gains a decisive advantage. At that point, power is no longer just about force or speed. It becomes about knowledge of position, knowing exactly where you are, where your target is, and how to move between those points becomes the foundation of everything else. Without that knowledge, even the most advanced systems lose their effectiveness. With it, even relatively simple systems can become extraordinarily precise. So when people think about modern warfare, they often focus on the visible elements, the drones, the missiles, the explosions. But the real transformation is invisible. It is the shift from uncertainty to precision, from estimation to calculation, from guessing where something might be to knowing exactly where it is. And once that shift happens, everything built on top of it begins to change. Once warfare becomes a problem of position, the next question becomes unavoidable. What is the system that actually provides that position with enough precision to make all of this possible? Because knowing where you are is not something that happens automatically. It requires a constant stream of information, a reference that everything can align to, and a system stable enough to be trusted in the middle of chaos. That system is GPS, not as a tool on the side, but as the central layer that everything else quietly depends on. It sits beneath the visible parts of modern warfare, connecting systems that would otherwise have no reliable way to coordinate with each other. And once you start looking closely, you begin to realize that many of the technologies people think of as advanced weapons are actually just extensions of this underlying system. Take drones, for example. A drone does not simply fly randomly through the air and then decide where to go. It follows a path defined by coordinates, constantly checking its position and adjusting its movement to stay on course, without a reliable reference for where it is. The entire idea of controlled flight over long distances begins to break down. What looks like intelligence is often just precise positioning applied continuously. The same pattern appears in cruise missiles. These systems can travel hundreds or even thousands of kilometers, navigating across complex terrain, adjusting their path as they move. But at every moment, they depend on knowing their current position relative to their intended path. Without that reference, even a small error at the beginning can grow into a complete miss by the end. Precision over long distances only works if position can be updated again and again with high accuracy. Even something as simple as a bomb has been transformed by this system. A conventional bomb, dropped without guidance, depends on estimation, altitude, speed, wind, and timing. But when combined with GPS, that same bomb becomes a guided system. It can adjust its path during descent, correcting for errors and steering itself toward a specific coordinate. The explosive power has not changed, but the effectiveness has increased dramatically because the uncertainty has been removed. And it is not only about individual weapons. Entire military operations depend on shared positioning. Units on the ground need to know where they are relative to each other. Aircraft need to coordinate with forces below, and different systems need to operate without interfering with one another. All of this requires a common reference, a way for every part of the system to agree on the same map of reality. GPS provides that reference, allowing separate elements to function as a coordinated whole. This is what makes the system so important. It does not just guide a single weapon. It synchronizes an entire network. Without it, each component would still exist. Drones would still fly, missiles would still launch, and bombs would still fall. But they would lose the ability to align with each other, to operate with precision, and to achieve consistent results. The difference is not in capability, but in coherence. What makes this even more interesting is that the system itself is almost invisible during operation. There is no dramatic signal you can see, no obvious indicator that everything is being guided by something external. It operates quietly, continuously, and in the background. And because it is so reliable, it is often taken for granted as if precise positioning is just a natural feature of the world rather than something carefully maintained. But once you remove that system, even in theory, the structure begins to collapse. A drone without reliable position data cannot maintain its path over long distances. A missile without continuous updates becomes increasingly uncertain the further it travels. Coordination between units becomes slower, less accurate, and more prone to error. The entire system shifts from precision back to estimation. This is why GPS is not just another piece of technology added to modern warfare. It is the layer that allows everything else to function at a higher level. It turns movement into controlled movement, turns weapons into precise instruments, and turns separate systems into a coordinated network. Without it, the visible power of modern weapons remains, but the precision that defines their effectiveness begins to disappear. And once you see that, it becomes clear that the most important part of modern warfare is not what is launched, but what is guiding it. Once you realize that so much of modern warfare depends on GPS, an uncomfortable question begins to emerge. What happens if that system stops working? Or worse, what happens if it is deliberately manipulated? Because while GPS feels stable and reliable, it is not invincible. In fact, it has a hidden weakness that comes directly from the way it operates. GPS signals travel from satellites orbiting thousands of kilometers above the Earth. By the time those signals reach the ground, they are incredibly weak. They have spread out over vast distances, passing through the atmosphere, competing with other sources of noise. This means that even though the system is precise, the signals themselves are fragile. And anything that is fragile can be disrupted. One of the simplest ways to interfere with GPS is something called jamming. Instead of trying to break the system directly, jamming overwhelms it with noise. A device on the ground can broadcast signals at similar frequencies, flooding the receiver with interference. The GPS receiver can no longer distinguish the real signal from the noise. And as a result, it loses its ability to calculate position. It is not that the satellites stopped working. It is that the receiver can no longer hear them clearly. At that point, the effect is immediate. A drone that depends on GPS for navigation begins to lose its sense of direction. It may slow down, hover, or drift off course. A missile that relies on continuous position updates may begin to accumulate errors in its trajectory. Systems that were designed to operate with precision suddenly revert to uncertainty. And this happens not because the weapon itself failed, but because the signal guiding it was disrupted. But there's an even more subtle and more dangerous method, something known as spoofing. Instead of blocking the signal, spoofing replaces it with a false one. A device transmits signals that look like real GPS data, but contain incorrect timing information. The receiver does not realize it is being deceived and calculates a position that is slightly or even dramatically wrong. This creates a different kind of failure. The system does not stop working. It continues to operate, but it operates based on false information. A drone may believe it is following the correct path while slowly drifting away from its target. A missile may adjust its trajectory with confidence, unaware that every correction is leading it further off course. From the outside, everything appears normal, but the outcome is quietly being altered. This is what makes spoofing particularly dangerous. It does not create obvious failure. It creates hidden error, and in systems that rely on continuous feedback, even a small error can grow over time. The longer the system operates under false assumptions, the further it moves away from its intended path. Precision turns into inaccuracy, and confidence turns into vulnerability. Because of this, GPS becomes not just a source of strength, but also a potential point of failure. The same system that enables precision can be targeted to remove that precision. And when that happens, the entire structure built on top of it begins to weaken. Weapons lose accuracy. Coordination becomes less reliable. And decisions are made based on incomplete or incorrect information. This creates a new layer of conflict that is less visible but just as important. Instead of only focusing on physical targets, systems now compete over signals, over information, over the ability to define what position means. The battlefield is no longer only on the ground or in the air. It extends into the invisible space of communication and timing. And this leads to a deeper realization. The effectiveness of modern warfare does not just depend on having advanced systems. It depends on protecting the integrity of the information those systems rely on. If the signal can be trusted, precision is possible. If the signal is disrupted or manipulated, even the most advanced technology begins to lose its advantage. So the hidden weakness of GPS is not a flaw in its design, but a consequence of its nature. It is a system built on signals, and signals can always be interfered with. And once that interference begins, the line between accuracy and error becomes uncertain again. Once you understand that GPS can be disrupted, manipulated, or even denied, a deeper question begins to take shape. If so much of modern warfare depends on this system, then who controls it? And what does that control actually mean? Because GPS is not a natural feature of the world. It is not something that simply exists on its own. It is built, maintained, and operated by nations. And that gives it a strategic dimension that goes far beyond technology. At first, it might seem like GPS is just a global utility, something everyone can use equally. And in a basic sense, that is true. Civilian signals are available worldwide, allowing phones, cars, and countless systems to determine their position. But underneath that public layer, there is a more precise and more controlled version of the system, designed specifically for military use. This version can offer higher accuracy, stronger signals, and greater resistance to interference. This means that access to precise positioning is not entirely equal. It depends on who controls the system, who can enhance it, and who can deny it to others. And once positioning becomes a central element of warfare, that control becomes a form of power. Not power in the traditional sense of explosives or force, but power over information, over coordination, and over the ability to act with precision. Different countries have recognized this, which is why GPS is not the only system in existence. The United States operates GPS. Russia maintains GLONASS. China has developed Beidou. And other regions are building their own systems. This is not redundancy for convenience. It is independence for security. No nation wants to rely entirely on a system controlled by another, especially in a situation where access could be limited, degraded, or altered, because control over positioning creates leverage. If a system can be restricted, even partially, it can reduce the effectiveness of anything that depends on it. Precision weapons become less reliable, coordination becomes slower, and operations become more uncertain. The system does not need to be completely removed to have an impact. Even small changes in accuracy or availability can shift the balance. At the same time, maintaining your own system ensures continuity. It allows a nation to operate without relying on external signals, to protect its own capabilities, and to ensure that its forces can continue to function even if other systems are compromised. In this sense, positioning infrastructure becomes as important as physical infrastructure. It is part of the foundation that supports everything built on top of it. This also introduces a new kind of competition, not just over weapons or territory, but over the systems that define how information flows. Control of GPS is not just about having satellites in orbit. It is about maintaining synchronization, ensuring accuracy, protecting signals, and integrating that information into every layer of operation. It is a continuous effort, not a static advantage. And because this system operates globally, its influence extends beyond any single battlefield. It affects navigation, communication, logistics, and timing across entire regions. The same signals that guide a missile also guide a ship, a plane, or a supply chain. This creates a situation where control over positioning has both military and civilian implications, blurring the line between the two. This is why GPS is often described as a utility, but in reality, it functions as a strategic asset. It supports everyday life, but it also underpins critical systems that depend on precision and timing. And in a conflict, the ability to protect your own access while disrupting your opponent's access becomes a powerful advantage. So when we say that modern warfare is about position, it naturally follows that controlling the system that defines position becomes a central objective. It is not about controlling every movement directly, but about controlling the reference that all movements depend on. And once you control that reference, you influence everything built on top of it. This leads to a simple but profound conclusion. The side that controls positioning does not just have better information. It has the ability to shape how accurately the world is perceived and acted upon. And in a system where precision defines effectiveness, that kind of control becomes decisive. Once you understand how deeply GPS is embedded into modern warfare and modern life, a final question begins to feel unavoidable. What happens if it disappears? Not partially, not degraded, but completely gone. No signal, no timing reference, no positioning system to rely on. At first, it might seem like an inconvenience, something people would quickly adapt to, but the reality is far more serious. Because so many systems depend on it in ways that are not immediately visible. In warfare, the effects would be immediate and profound. Precision weapons would lose their defining advantage. Drones would struggle to maintain long-distance navigation. Missiles would accumulate errors as they travel, and guided systems would revert to less reliable methods. Strikes that once depended on exact coordinates would become uncertain, and the gap between intended target and actual impact would begin to widen. The shift would not be subtle. It would fundamentally change how operations are planned and executed. Coordination would also begin to break down. Units that rely on shared positioning would lose a common reference. Movements would become slower. Communication would require more confirmation, and the risk of misalignment would increase. What was once a synchronized system would become fragmented, each part operating with less certainty about where others are. The overall efficiency of operations would decline, not because of a lack of capability, but because of a lack of precise information. But the effects would not stop at the battlefield. Modern society, in ways that most people rarely think about, depends on the same system. Aircraft use GPS for navigation and routing. Ships rely on it for positioning across open oceans, and logistics networks use it to track and coordinate the movement of goods. Without it, systems that appear stable would begin to show strain. Delays would increase, routes would become less efficient, and the margin for error would grow. Even time itself, as used in many systems, would be affected. Financial networks, communication systems, and infrastructure rely on precise timing to stay synchronized. GPS provides not just position, but a shared clock. Without that reference, systems that depend on coordination and time would begin to drift, and small discrepancies could grow into larger disruptions. It is not just about where things are, but about when things happen. What makes this scenario so striking is that nothing physical needs to be destroyed. No buildings need to collapse. No infrastructure needs to be visibly damaged. The disruption comes from the absence of a signal, from the removal of a reference that everything quietly depends on. It is a form of fragility that is built into the system itself, a reliance on something that is always there until suddenly it is not. Over time, alternative methods would emerge. Systems would fall back on inertial navigation, visual tracking, or other forms of estimation. But these methods are often less precise, less reliable over long periods, and more prone to accumulating error. The world would not stop functioning, but it would become less accurate, less efficient, and more uncertain. And that uncertainty changes behavior. Decisions would become more cautious. Operations would require more redundancy, and the confidence that comes from precise knowledge would be reduced. The shift would not just be technical, it would be psychological. When you are no longer certain about position, every action carries more risk. This leads to a final realization that ties everything together. GPS is not just a convenience, and it is not just a tool. It is a foundation that modern systems are built upon. It quietly provides position and time, allowing complex systems to function with precision. Remove that foundation, and the structures built on top of it begin to weaken, not all at once, but gradually as uncertainty spreads through every layer. So the most important weapon in modern warfare is not something that explodes, and it is not something you can see. It is the ability to know exactly where things are and to trust that knowledge completely. And that ability depends on signals that travel invisibly through space, connecting satellites, systems, and decisions into a single coherent picture of the world. Take that away. And the world does not just become less advanced, it becomes less certain.